Hi folks, this is Matt Jackson again, and so now let's take a look at mixed strategy Nash equilibrium in practice and try and understand a little bit about what it can tell us about what we should expect to see. So let's start with the situation of soccer penalty kicks, and this is a quite natural application of mixed strategy equilibria because they're ubiquitous in sports and competitive games, so situations where it actually pays to be unpredictable. So by not knowing what the opposition is going to do, it makes it a little more difficult for you to pick an optimal strategy in these games where one player wins and the other player loses. And in particular, in soccer penalty kicks, we're looking at a situation where a kicker has to try and kick the ball into the goal. The goalie can try and move to deflect the ball. And this happens very quickly, so it's essentially a simultaneous move game. The kicker is choosing to go either in their simplified version, say to the right or the left. The goalie is then going to dive to one side or the other side and try to deflect the ball. And if the goalie guesses correctly and ends up in the same direction as the kicker, then they have a higher chance of saving it. If they go in an opposite direction, they have a lower chance of saving it. Okay, so how are equilibria going to adjust to the skills of the players? So let's suppose, for instance, as a kicker, that I might be biased. I might be able to kick the ball more accurately in one direction than the other. So if you ask me to kick it towards the left side of the goal, it might be that I hit there very accurately. If you tell me I have to kick it towards the right side of the goal, it could be that I'm less accurate and I have a higher chance of just missing the goal altogether. So how is the equilibrium going to adjust when we change one of the players' adjustments in terms of their skills? So let's have a peek at this. Should a kicker who kicks penalty kicks worse to the right than the left kick more often to the left than the right? So if I'm worse in kicking towards the right, does that mean I should kick in the opposite direction more often? Well, let's have a peek. So let's start with just the simple version just to get our ideas fixed. So imagine that the setting is one where the kicker and the goalie, so let's have the kicker on this side. So the kicker is the row player, the goalie is the column player, and if they end up kicking, if the kicker goes left and the goalie also happens to go to the left, then the goalie saves and the goalie gets a payoff of 1, the kicker gets a payoff of 0. If instead we're in a situation where, say, the kicker goes left and the goalie goes right, then the kicker scores and gets a payoff of 1 and so forth. Okay, so this is just a simple variation on matching pennies, and in this situation, what's the equilibrium going to be? The equilibrium is going to be quite simple. It's just going to be that the kicker randomizes equally between left and right, the goalie randomizes between left and right. Each person has a probability of half to win from kicking to the left or right, going left or right. So it's a very simple game, and we have a good idea of how to solve that one. Okay, so now what are we going to do? Let's change things. And now we've got a kicker who sometimes misses when they go to the right. So in particular, if the goalie happens to go to the left and the goal's wide open to the right, the kicker scores 75% of the time, but actually misses completely 25% of the time. Okay, so this is a kicker who still does well if they go left and the goalie goes to the opposite direction, but now they have a lower probability of winning when they're kicking right and they have a wide open goal. Okay, so how should this adjust? What should the new equilibrium look like? So let's suppose, let's first of all try and keep the kicker indifferent. So let's think of the goalie going left with probability P, right with probability 1 minus P. For the kicker to be indifferent, what has to be true? Well, what's their payoff if they go left? Their payoff to going left is just 1 times 1 minus P. Their payoff to going right is 0.75 times P. These two things have to be equal in order to have the kicker be indifferent. So what do we end up with? We end up with 0.75 P is equal to 1 minus P. So we end up with 1 equals 1.75p, or p is equal to 1 over 1.75, which is equal to 4 over 7. Okay, so that tells us that the goalie should be going left with probability 4/7 and right with probability 3/7. Okay, so we know what the goalie is supposed to be doing. So now the fact that we changed the goalie's payoffs haven't changed, but the fact that we changed the kicker's payoffs meant that the goalie actually had to adjust, right? So even though the goalie's payoffs haven't changed at all in this game, the new equilibrium has a different set of probabilities for the goalie in order to keep the kicker indifferent now. Okay, so now let's see what the kicker is going to do. So how are we going to see what's... So let's suppose that the kicker goes left with probability Q, right with probability 1 minus Q. And let's solve for Q. Well, for the goalie to be indifferent, what is their payoff if they go left? If they're going left, they're getting a Q probability that they match. So they get Q plus 0.25 times 1 minus Q if they go left. If they go right, instead, what are they getting? They're just getting 1 minus Q, right? So these two things have to be equal. So we end up with Q is equal to 0.75 times 1 minus Q. So Q over 1 minus Q is equal to 0.75. What does this tell us about Q? That tells us that Q is equal to 3/7. Okay, so what's going to happen when we work out this, we get 3/7 for the probability that the kicker is going to go left and 4/7 for the probability that the kicker is going to go right. So overall, what do we have now? We have the strategies looking like this as we made this adjustment. And we notice two sort of interesting things about this. One is that the goalie's payoffs didn't change, but they still had to adjust their strategies. And the second is that the kicker is actually kicking more often to the weaker side, right? So their right foot got worse than it was before, and they're actually going in that direction more often. And why is that? It's because the kicker, the goalie, has also made an adjustment in this game. And so the comparative statics in mixed strategy Nash equilibria are actually quite subtle and somewhat counterintuitive in terms of what you might expect. You get a bias so that this becomes a weaker direction, and the equilibrium adjusts so that the player goes in that direction more often. So let's have a look just through the intuition here. Again, the goalie strategy must have the kicker indifferent. And so when we went through those payoffs, the goalie goes left more often than right. And the kicker actually, so sorry, there's a typo here. The kicker actually goes right more frequently, right? Goes right with probability now 4/7. So they've increased their probability on that. And when we end up, what we see is the goalie strategy is adjusting, but we also see that the kicker adjusts to kicking more towards their weak side. So the goalie now actually has a slight advantage. So if you go through and calculate the probability that the goalie is going to win, they're going to win 4/7 of the time in this match. And we can think, what would happen if the goalie actually just stayed with their old strategy of still going 50-50? Then the kicker could always go left and win half the time instead of 3/7. So the fact that the goalie has to make an adjustment is because they have to defend more to the left side to defer, because now the kickers has a better chance of winning on that side. So the goalie goes more in that direction. That pushes the kicker towards their weaker side in order to make sure that the goalie is willing to go to the left side with a higher frequency. So by adjusting the strategy to keep the kicker indifferent, the goalie actually gets advantage of the kicker's weak right kick and wins more often. Okay, so just in terms of summary and mixed strategy and soccer penalty kicks in general, players must be indifferent between the things that they're randomizing over. That produces very interesting and subtle comparative statics. And there's a question that might come up in your mind. Do people really do this? I mean, this is fairly complicated, right? So, 50-50 we can figure out. Once we get these games where a player has an advantage one way or another, then the actual mixture becomes fairly complicated, and it's not so obvious that players will actually do that. So we'll take a look at that and see if this actually bears out in practice.